So here is one of the most popular biasing technique for the bipolar junction transistors, and it is called as voltage divider bias circuit. So as we can see, you have an NPN transistor which has three pins such as collector, base and the emitter. The voltage across the base and the emitter would be termed as VBE, and voltage across the collector and the emitter is termed as VCE. So with the supply voltage, what we see, we use two resistor R1 and R2 that sets a DC operating point for this transistor. So with the voltage division formed by R1 and R2, the voltage across R2 is applied to the base emitter junction, and the voltage across R2 can be calculated as VR2, that will be equal to, that is the voltage across R2, this is VCC multiplied by resistor value R2 divided by R1 plus R2. So you see, it's a simple potential divider rule. So that voltage is applied and you have this VBE right here, and then there is a current IE, that is emitter current, that flows through this RE, and therefore that's the loop. You can apply the KVL in this loop to know the voltages and the currents. Similarly, for the outer circuit of the BJT, you can apply the KVL in the outer loop, which is VCC minus ICRC, that is collector current that flows through the RC, minus VCE, this drop, minus IERE, and equate it to 0. So there are two loops that you can apply. Here the current IB can be evaluated, you know, that's the current IB, that's the current IC and current IE. So with this, you have set a DC operating point for the transistor. Similarly, the value of the current IB can be written as IB will be equal to I1 minus I2. That's the subtraction of I2 from I1. So this is the voltage division circuit that you can apply.